we're looking at Unit C solutions, and the topic of major entities in solutions. So what we're basically talking about when we're talking about major entities in solution is when I put something into water, what are the major players that are present in that water? Okay, and so what we need to determine first is the type of substance that we are dealing with. So we have a few different options, at Chem 20 for things that we can go to, and these are the four options. So all of the substances that we're going to look at are either going to be ionic compounds, molecular compounds, they're going to be acids, or they're going to be an element from the periodic table. So let's go through one by one and see if we can come up with some guidelines to help us get through this. Okay, so let's say we determine the substance is an ionic compound, it's a metal and a non-metal, and we have to decide what's going to happen when we put it in solution. So let's say we have something simple. Oh my gosh, can I draw on this? Okay. So let's say we have something simple, sodium chloride table salt. Okay. Now I see this, I determine it's ionic. What's the next thing that I need to do? Well, I need to go determine when I drop this in water, is it going to be soluble or is it going to be not soluble? And so where do I do that? I'm going to go to the solubility table. So most of us already know that NaCl is highly soluble in water. So when I put this salt into water, what's going to happen is it's going to separate or dissociate into a bunch of positive and negative ions. So I would say that the major entities that are present in this salt water are sodium ions, chloride ions, and the other thing is, well, water. Okay, so those are the major entities in salt water. Okay, now let's say I come across something like this. So I say, okay, this is an ionic compound. It's a metal, silver, and chloride ions. So we have silver chloride here. It's solid, and then we drop it into water. So we want to figure out what's going to happen. We're going to need to go over to our solubility table here. And usually what you're going to be looking for is the anion. And the anion, in our case, the negative ion, is chloride. And so when I go down here, I see most things are highly soluble with chloride ions. But if I go down a little bit further, I see here silver. So silver chloride is low solubility, so it's not going to dissolve very well in water. So if I go back here, I'm going to essentially, when I drop this into some water, I am going to get a hunk. It's an ionic compound, okay, of silver chloride at the bottom of this beaker, and so that's going to leave me with the major entities are that clump of silver chloride and water. Okay, so with ionic compounds, you need to determine if it's highly soluble or slightly soluble, low solubility, and go from there. Okay, so let's look at molecules now. So for a molecular compound, two nonmetals, we have to determine whether those are going to dissolve in. Get out of here. Whether those are going to dissolve in water. So if you want to look at that, well, let's look at an example here. So let's do ammonia. Okay, NH3, it's generally a gas at room temperature at SATP. And so we want to decide, okay, when I put ammonia gas into water, is it going to dissolve or is it not? And we don't have a solubility table for molecules, but we do have the general rule that like dissolves like. So if something is going to dissolve in water, a polar molecule, it needs to be polar. So there's a little overlap from bonding here. But what we're going to see here is when I look at my NH3 molecule, I'm going to have this trigonal pyramidal molecule. It's got that lone pair up there. and that makes it a polar molecule. So it's going to dissolve, ammonia is going to dissolve in water. But the different thing in with molecules is molecules do not separate into their constituent atoms. They remain as molecules. They just spread out. They just disperse. So if I have, a NH3 dissolved in water, those NH3 molecules are just going to spread out. They don't split up into ions or anything like that. They don't split up into nitrogen and hydrogen atoms. They just split up into a whole bunch of little NH3 molecules, and they spread out evenly throughout my water. So my major players here, my major entities, are NH3, and now it gets the aqueous. It's dissolved, so it's aqueous and water. Okay, those are my major entities. Now let's say we have something like this, okay, CH4. That's methane gas, and you guys for hydrocarbons have learned that all hydrocarbons in general are non-polar molecules, right? If I were to draw this molecule, I would get, what kind of shape is this again, kids? Tetrahedral. So this tetrahedral shape is a perfectly balanced molecule. So it's a non-polar molecule. And so when I put methane into water, it's going to, it's not going to mix. It's generally going to remain, on top of the water. It's probably going to actually escape from the water. But if we stick it in the water, we don't let it escape, it's not going to mix evenly or dissolve in the water. So your major players here will be some bubbles of, CH4 gas and some water. Okay, so those are your major players there. Okay, now for acids. Okay, so let's say we determine something is an acid, and how do we do that? One of the things that we can do as a little trick is acids are generally going to start with H, or they're going to end in COOH. Those would be a weak carboxylic acid. And the other thing we can do is we can, take a look up here at our acids table from our data booklet and see if we can, find the acid that we're looking for, find the substance that we're looking for. If I see, H3PO4 starts with an H, I can go check this table and be like, oh yeah, that's an acid. It's phosphoric acid. Okay. So with acids, we need to determine if they are strong acids or weak acids. Strong acids are going to form ions in solution. They're going to do what's called ionize, and weak acids are going to do that, but only a small amount, and that's why they're weak acids. And so the major players, the major entities in solution, we're going to have acids, strong acids ionize into ions, and weak acids are going to stay together. They're going to remain as the molecule. So let's see what that would look like. So let's do a strong acid. Everybody knows HCl. And so let's say I put HCl, and HCl, anhydrous HCl is a gas. You might see aqueous here before. You might see aqueous used here as well. It doesn't really matter. What matters is the end product, what is in there at the end. So HCl is going to do something called ionization, since it's a strong acid. Now, the strong acids, I should mention, are your top 6 in the table here. These are your strong acids. These are the ones that are going to ionize in solution. And so when this happens, I'm going to get hydrogen ions. Those are my positive cations. And I'm going to get some chloride ions. Those are my negatives. And so that's called ionization. So when this is done with, I'm going to end up with hydrogen ions in solution. I'm going to end up with chloride ions in solution. And I'm going to end up with some water in there. Okay, those are the major players in that beaker. Okay, now let's say I have a weak acid. So common weak acid, acetic acid or ethanoic acid, which is vinegar, CH3COOH. Let's give it a liquid. You might see aqueous there as well, as it is an acid. But let's say this is, without the presence of water. Again, it doesn't really matter. What matters is what you have at the end. So with this is weak. This is a weak acid. And so it's only going to ionize a little bit. So the major entities in solution are going to remain that ion, that molecule, CH3COOH, but now it gets the aqueous. It has high solubility. It dissolves in water, but it remains as the molecule. So it spreads out throughout the water, but it doesn't produce those ions. And my other player in this beaker is water. Okay. Now on to elements. Okay, so if we have an element, this one is easy. Elements are all low solubility in water. So let's say I have, oxygen gas, and I want to put that into water. It is not going to dissolve. It's going to be, all together. It's not going to separate or disperse, as we say. So the major entities in this beaker right here would be some O2 gas and some water. Okay, and that would be the same for any solid or liquid element from the periodic table. Okay, so in summary, you want to determine the type of substance first. If you determine it's ionic, you go to the solubility table. If it's high solubility, like sodium chloride, it's going to dissociate into its ions. If it's low solubility, like silver chloride, it is going to remain as the compound, and it's going to remain with that S for solid, and it's not going to dissolve in water and get that aqueous. Okay. If you determine it's a molecule, you have to look to see, is it polar? And remember that rule of like dissolves like. If it's polar, okay, so this is polar. If it's polar, it's going to dissolve in water, but it doesn't separate into its atoms. Okay, it remains as a molecule. They just spread out throughout the solution. If it is non-polar, like methane here, then it's going to remain as the molecule, and it's also not going to dissolve. It's not going to mix in with the water here. It's going to remain on its own. Okay. If you determine you have an acid, so something that starts with H or ends with COOH, you are going to look at your acid table, and you are going to determine if it is a strong acid like HCl. In that case, it is going to ionize, and it's going to form ions in solution. If it is a weak acid like acetic acid here, it's going to dissolve. Okay, so it's going to get that AQ, but it's not going to form a large amount of ions. So the major player there is just the molecule CH3COOH and water. And if it's an element, it is always low solubility. Okay, so I hope that helps, kids. And if you have any questions, you know where to find me.